All right, good afternoon. Today's lesson is on basic electricity. This is our electronic trainer. Today we're going to do a couple things. We're going to go over the basic training parts on the trainer, the procedures. We're going to do two exercises. One which consists of setting up a circuit, showing just how a circuit is set up using the trainer. And then two, we're going to go into practice Ohm's law, which you'll see in your slides what the theory of Ohm's law is, what the equation is, but we'll compare it versus a parallel system versus a series to show you how it works. So going into it real quick, we're going to start here. This is the power cable. This is the main power switch that actually turns on the unit. There's a breaker. This is the power selection button. This is actually where the power is going to kind of be fed from. You have different types of resistance. There's your fuse. Resistor here is a transformer. You have some resistors here, different ohms for resistance. We have a couple different switches. We have a knife switch. We have a push button switch, a selector switch. We have some lights so we can visually see exactly what's going on. We have a buzzer. We have a fan. We have some other type of resistors down here and a solenoid to use, which we won't use in any of ours. Also a capacitor, which they actually will hold a little electricity. When you're working with the electronic trainer, you want to make sure that you use your safety practices. Make sure that it's ground, which we are using a 3-prong plug, and making sure that you're using any other type of safety happens you need. You may need to use safety glasses. You can also use your trusty multimeter if you need to verify that certain things are working or not working. First thing that we'll do is we're going to install a circuit using a light to show that it is working. We're going to use AC. So we'll plug in everything. The power is still off. We'll plug in our unit to make the light work. In doing so, we're just building a simple circuit. And what you do is you remember a circuit starts in one location and ends in another. So what we have is we have the switch from power to the light, from the light, through the light, back to its power source. It's connected on AC, and so pretty much all that's left to do is kind of flip the switch. It's kind of a switch at your house, switch here in the classroom. Comes on, and you see the light comes on right there. Turn the light switch off, and what we could do is we could continue building another switch if you wanted to. Come from here to another light. Actually, not this one, not that hard to do. Making it harder than it should be. And bringing it back to our power source here. Turn the switch on, we should have two lights are lighting up. Now you also see that they're a little dimmer. We'll talk about that more when we talk about series and parallel. All right, remove all of our items. Next thing we want to do is showing the light coming on through some sort of a button. In this case here, going from the power to a switch of some sort. Let's just use a push button. Through the push button to a light, then a light, back to our power source. And so if I flip the switch, you see the power is on, the light's not, until we push the button, closing the circuit, allowing the light to come on. Turn the power switch back off, and remove all of the leads. Next one we're going to do, we could do the same thing through a different type of switch. There's a switch here, or a selector switch, which we could do. Let's just move on forward to the actual buzzer itself. That way we can hear an audible sound. This time what we'll do is we'll connect it through a connector switch so that we can turn the buzzer on and off when we want to, and then bring it back through the buzzer, which is at this location. Bring the buzzer back to the power here. We should have a completed circuit. We'll flip the switch. Nothing happens until we hit the selector switch. And as you can see, the buzzer is going off. We turn it back off. The buzzer is working. Remove it. Now what should happen? Obviously, if we wired it up wrong, the switch necessarily wouldn't work. Okay, we'll move into a series, a demonstration between a series and a parallel. First one we'll build is a parallel. I'll take that back. First one we should build is a series. I want you to show you Ohm's law, which is the resistance. You can see the resistance actually grow. We'll start at the AC power, and we'll move to one light. Hence, by going in series, we're connecting each one of them, each load or each resistance, in order, one after another to another, eventually making our way back to the power source. And in doing so, we've created a series. And in doing so, what do we think would happen? Well, we'll turn the light on. And in doing so, you can see the lights all light up. They're very dim. Yes, they are lit, even though you probably barely see those things. Whereas, if you remember, earlier we showed the light was very bright. So, we'll shut it off. We'll show you the difference of what the light should be looking like, one at a time. If we lit up each light, you'll see how bright the light should be, indicating that the resistance is drawing the current down as you hit each resistance. If you remember that in a series, the volts or drop is determined by the resistance of each load. So in this case, the resistance of each light bulb is drawing the voltage down, and then the current decreases as the resistance are loaded or added, and then they would increase. As you see here, the light is brighter. And then if we come through and we add another light, quickly, we'll add another light to the series, turn the switch on, and you'll see the lights are brighter than the 3, but not as bright as the 1, which really shows that the current is reducing as the resistance loads. And it's the same as resistance. The resistance is the sum of all resistors, increasing when the loads are added and decreasing when the loads are removed. Okay, we'll turn the system off. We'll pull off all the leads, and then lastly we'll do the parallel circuit, which, if you know the rules behind the parallel circuit, the current is equal to the sums of the current through the loads. They increase as the loads are added, decrease as the resistance of the loads are removed. The voltage is the same throughout the loads. That is the catch. That's what you'll be able to see visually. The resistance is less than the distance of the value, which decreases when loads are added, and they increase when the loads are removed. So what you'll see in this case is you'll see a parallel circuit. And what we'll do is we'll make the lights, have the lights all add up on their own. And they all should be about the same brightness. So what we're doing is we're adding a parallel circuit here. Whereas, you can see, we're coming from the power source to each one of the lights, and then bringing each one of the lights back to its own source. Takes a little more leads than the last one, but as you'll see, it makes a big difference when you're calculating Ohm's law and trying to achieve the product that you're having. So when I turn the system on, what do you think you'll see? Will you see the bright lights all the way across? Will you see a dimmed lights? I don't know. Let's find out. You see bright lights. So what's happening is that the resistance is being reduced because I have parallel circuits. I have 3 series circuits, or in this case, 3 individuals being served through a parallel system instead of through a series circuit. So today's demonstration was Ohm's law visually found. We showed you the series, and then we went through and showed you the actual parallel circuit that went through the process. So you should be ready to go through the notes and take your exams.